Welcome to this presentation. I'm Claudio Menghi. The work I'm going to present is titled Approximation-Refinement Testing of Compute-Intensive Cyber-Physical Models, an approach based on system identification. This work has been developed in collaboration with Shiva Nejati, Lionel Briand, and Iago Isasi-Parac. The high-level goal of this work is to help engineers in developing and analyzing cyber-physical system models. Our focus is on industrial cyber-physical system models. These models are often compute-intensive. A compute-intensive cyber-physical system model requires hours to complete a single simulation. This is the usual case in industrial settings, where cyber-physical system models are complex and include many components, often developed by third parties. For example, a single simulation of our case study, a real model of satellite provided by our industrial partner, requires 1.5 hours to complete a single simulation. Classical testing frameworks require to simulate the model a high number of times for detecting errors. Simulating many times a compute-intensive cyber-physical system model requires an enormous amount of time, to the extent that automatically testing those models is impractical, if not even impossible. Therefore, classical testing techniques cannot be used for handling compute-intensive cyber-physical system models. Our goal is to develop a testing approach that can analyze compute-intensive cyber-physical system model effectively and efficiently. Our solution is called ARISTEO, Approximation-based Test Generation. ARISTEO takes as input a model under test that is compute-intensive. To make the testing approach feasible, the first step of ARISTEO is to learn an approximation of the original model. The approximation activity is represented in our slide by the approximation box. The approximation learns a surrogate model that can be executed faster than the original model. Then ARISTEO performs the testing activity on the surrogate model. The testing activity is represented by the falsification box. The testing activity evaluates the outputs of a high number of test cases on the surrogate model. It finally selects a single candidate test cases that is more likely to show a violation on the original compute-intensive model. The returned single test case is evaluated on the initial compute-intensive model. The evaluation of the test case on the initial compute-intensive model is represented by the checkbox. If the test shows a violation on the original model, it is a failure-revealing test and it is returned as output. Otherwise, it is a spurious failure. If the test is revealing a spurious failure, the surrogate model is refined. The refinement activity is represented by the refinement box. It aims at refining the original surrogate model to better approximate the dynamics of the system. After the model is refined, the loop is repeated. The ARISTEO loop ends in two cases. It stops whenever a failure-revealing test is found, or whenever ARISTEO exceeds a time budget that is provided as parameter. To implement ARISTEO, we had used falsification-based testing for the falsification and the checking activities. And we had used Stolero for their implementation. Stolero is a falsification-based tool recently classified as ready for industrial development. For the approximation and refinement activity, we had used system identification. System identification is a set of techniques that allow learning model approximation from input and output data. We had used the MATLAB system identification toolbox for their implementation. Our tool is provided as a MATLAB standalone application and is made publicly available. To evaluate ARISTEO, we had considered two research questions. The first research question aims at measuring how effective is ARISTEO in generating tests that reveal requirements violation. The second research question aims at measuring how efficient is ARISTEO in generating tests that reveal requirements violation. To answer these questions, we had compared ARISTEO with Stallero. Running this comparison by considering compute-intensive cyber-physical system models is impossible. First, these models are hard to retrieve, since cyber-physical system models coming from academy are usually not compute-intensive, and models coming from industry are usually hard to be retrieved. Furthermore, running such a comparison would have required an absurd amount of time. Our experiment would have required several years of computation before providing any statistical significant results. Therefore, we had used non-compute intensive cyber-physical system models for this comparison. Our results show that ARISTEO is more effective than Stallero. ARISTEO detected on average almost 24% more violation than Stallero. Our results also show that ARISTEO is more efficient than Stallero. ARISTEO is on average 31% more efficient than Stallero. To complement the results of research questions 1 and 2, we had considered how applicable and useful were ARISTEO and Stallero or an industrial compute-intensive cyber-physical system model. We had considered the model of the satellite provided by our industrial partner LabSpace, and we ran ARISTEO and Stallero to check for violations. ARISTEO was able to compute a violation in approximately 4 hours by running only 2 simulations of the model under test. Stallero was not able to detect a violation within the same time budget. Therefore, our results show that ARISTEO efficiently detected requirement violation in practical time that Stallero could not find on an industrial, compute-intensive cyber-physical system model. To conclude, we had defined and implemented ARISTEO, an approximation-refinement-based testing approach for compute-intensive cyber-physical system models. We had compared ARISTEO with Stallero, an existing testing tool for cyber-physical systems. Our results show that ARISTEO can efficiently and effectively handle compute-intensive cyber-physical system models. Furthermore, we were able to detect problems in a real model of a satellite provided by our industrial partner LabSpace. Thank you for your interest and your attention.